Radiation is frightening. At least certain types of it are. I mean, my Geiger counter doesn't go off near my mobile phone or the Wi-Fi router or my microwave. That's because a Geiger counter only measures ionizing radiation. That is, radiation with enough energy to rip electrons off atoms. And it's measured in units called sieverts. If you're exposed to more than 2 sieverts all at once, you'll probably die shortly after that. But we're exposed to low levels of ionizing radiation all the time. Bananas, for example, are rich in potassium, and some of that potassium is naturally radioactive. So when you eat a banana, you're actually exposed to about 0.1 microsieverts of radiation. That's 1/10,000,000th of a sievert. Let's use a banana for scale of radiation doses. You know, since people eat bananas, we become radioactive too. So you're actually exposed to more radiation if you sleep next to someone than if you sleep alone. But I wouldn't worry about that, because that dose is insignificant compared to the natural background radiation of Earth. I mean, there's ionizing radiation coming out of the soil and the rocks and the air and even from space. The level of radiation here in Sydney is about 0.15 microsieverts per hour. And that's about average globally. The level's usually between 0.1 and 0.2 microsieverts per hour. But there are places with significantly higher levels. So who on Earth do you think receives the maximum dose of ionizing radiation? Let's answer that question by going to the most radioactive places on Earth. Some places you'd expect to have high levels of radiation might surprise you. I'm in Hiroshima, and that is the Peace Dome. It was about 600 meters above that dome where the world's first nuclear bomb was detonated over a city. It was detonated there to have maximum destructive impact. With a level of radiation today, almost 70 years later, is only 0.3 microsieverts per hour.
I'm about to get into an elevator. We're going down the mine shaft. This is an old uranium mine.
This is the mine where uranium was discovered. It's also the place where Marie Curie obtained her raw material.
1.7 microsieverts per hour. It's about 10 times the natural background that you would have.
Nowadays, most of the uranium has been removed. But in this wall, there's still a small piece, and you can see under UV light, it fluoresces.
Look at that. Fluorescent uranium ore.
This is the lab of Marie Curie. She won 2 Nobel Prizes, one in physics and one in chemistry. And she conducted a lot of her work here. And this is her office. She would have sat right there. Apparently there are only a few parts of this area which are still radioactive. One is this doorknob.
Well, it climbs not much,
But that's like 10 times the background.
yes, more than 10.
And another is the back of her chair. You can still detect alpha particles coming off this spot right here. Apparently after she was working in the lab, she would come, open the door, leaving traces of radium here, and then go and pull out her chair. Welcome to New Mexico. This is the Trinity bomb test site where the world's first nuclear bomb was set off. Right here, right in this spot. This whole area was vaporized. In fact, there was so much heat liberated by that bomb that it fused all of the desert sand into this green glass. And you can still find it here. They've actually named this mineral after the test. It's called Trinitite. Yeah, this is the only place on Earth that this has ever been made. The level of radiation here is about 0.8 microsieverts an hour. The Trinitite itself is a little bit more radioactive. I got readings of 2 or 3 microsieverts an hour off them. Now, which place has higher levels of radiation than anywhere we've seen so far? The answer is an airplane. You know, as you gain altitude, there's less atmosphere above you to shield you from cosmic rays. So the level of radiation inside the plane can go up to 0.5 microsieverts per hour at 18,000 feet, up to 1 microsievert per hour at 23,000 feet, over 2 microsieverts per hour at 33,000 feet, and over 3 microsieverts per hour at even higher altitudes and towards the poles. That is Chernobyl nuclear reactor number 4. It melted down on April 26, 1986. So what happened was so much heat was generated inside that reactor that it basically blew the top off, spreading radioactive isotopes throughout this whole surrounding area and over into Europe. And that is why we can still detect the contamination here today. Now right now it's reading around 5 microsieverts an hour. If I stayed here for 1 hour, my body would receive a similar dose to what you'd receive when you get a dental x-ray. So this is not a huge amount of radiation. And one of the reasons why the radiation level is not too high is because they actually removed a couple meters worth of topsoil from this whole area, and then they dumped it somewhere. That's why we can stand here. We're driving into the Fukushima exclusion zone now. I'm just watching as the levels on my Geiger counter go up as we approach the zone. See those black bags at the side of the road? The Japanese are doing now exactly what the people in Chernobyl did, collecting up meters and meters of topsoil. The mask is probably overkill. It's just to stop radioactive dust from getting into my lungs. This is definitely one of the most radioactive places where I've been. Even though the release of radioactive material was less than Chernobyl, only about 10%. Because it's much fresher, only 3 years since the accident, much less of it has decayed. So I've been getting readings up around 5 to 10 microsieverts an hour. And I think we won't be staying here for too long because of that. I'm about to go into the hospital at Pripyat, and this is where the firemen were taken after they fought the fires at the Chernobyl reactor. And in the basement of this building, they have left all of the firemen's clothing. Once they realized it was so contaminated, they chucked it down there.
That shoe? 80.
But you can see there's a huge pile of that gear there.
Right outside the door, I'm getting 500 microsieverts an hour just outside the door. 1,500 microsieverts an hour. You know, if we stayed here for a couple hours, we'd receive our annual dose of background radiation.
That basement was the most radioactive place I visited, and it's one of the most radioactive places on Earth. If I'd stayed down there for 1 hour, I would have received 2,000 microsieverts. That's a year's worth of natural background radiation. Every yellow pixel here represents a banana. Now that might seem like a lot, but consider that in a CT scan, the patient receives about 7,000 microsieverts. That's 3 years worth of natural background radiation. It's been estimated that the people living around Fukushima will receive an additional 10,000 microsieverts over their lifetime due to the nuclear power disaster. For comparison, US radiation workers are limited to a maximum of 50,000 microsieverts per year. But that's less than another occupation, astronaut. An astronaut on the space station for 6 months will receive about 80,000 microsieverts worth of radiation. But not even they are exposed to the highest levels of ionizing radiation. So can you guess who is? The answer is a smoker's lungs. A smoker's lungs on average receive 160,000 microsieverts worth of radiation every year. That's due to the radioactive polonium and radioactive lead in the tobacco that they're smoking. So not only are they exposed to carcinogens and toxins, they also receive very high levels of radiation. So it's not the people of Fukushima or Chernobyl or radiation workers or even astronauts who receive the highest doses of ionizing radiation. That honor goes to your ordinary, average smoker. Hey, as you can see, over the last few months I've been traveling around the world actually filming a documentary for television. It should be on in the middle of next year. But being in places like Chernobyl and Fukushima reminded me of this book, The Day of the Triffids. It's about a post-apocalyptic world in which plants take over. I know it sounds like a crazy idea, but it's actually a brilliant book, so you should really check it out if you're looking for something to do over the holidays. Now, you can download this book for free by going to audible.com/veritasium, or you can pick any other book of your choosing for a 1-month free trial. Audible is a great audiobook website with over 150,000 titles in all areas of literature, including fiction, nonfiction, and periodicals. So I really want to thank Audible for supporting me, and I want to thank you for watching.